Hello people, welcome back, and today we're going to be practicing some exam questions for chapter 9. Specifically, we're going to be looking at fractional distillation, okay? Now, I set the link in the description to the actual exam question so you can have a go yourself, and then you can press pause on the video, and as we go along discussing the answers, you can self-mark your answers yourself, okay? But before we get into that, a massive thank you to these guys again, okay? They have subscribed to the channel, they have left comments. Thank you very much. It's very much appreciated. And remember, if you find this useful, like and subscribe, give us a hand, and yeah, so let's jump into it.
It was a nightmare.
Activate.
Okay guys, so here we got a question about crude oil, and we're looking at fractional distillation, okay? Now it says here, describe how crude oil is separated into fraction, okay? So the first thing we got to remember is that the crude oil needs to be turned into a vapor before it's pushed into the fractional column, okay? So first mark, you would say the crude oil is heated and turned into a vapor. After that, the crude oil is going to be pumped into the fractional column where the hot air, the hot gases will rise to the top. Right, the crude oil is going to be pumped into the fractional column, and as the gases rise, the ones with the long hydrocarbon chains are going to condense towards the bottom of the fractional column, and the ones that have small hydrocarbon chains will condense towards the top, because the bottom of the fractional column is hotter than the top of it. As you go to the top, it gets cooler and cooler, so it is not hot enough to maintain those long hydrocarbon chain molecules in a gas state, so they will condense into a liquid and then they can be extracted. Like we said, as the gases rise, the long hydrocarbon chain molecules condense, and the small hydrocarbon chains rise up the fractional column. Because the small hydrocarbon chains have small intermolecular forces, they can very easily turn into vapors, whilst the long hydrocarbon chains, they have stronger intermolecular forces. It takes a lot more energy in order to break them apart and turn them into an actual gas. The fractions have different boiling points, and that's why they condense at different levels of the fractional column, because there will be different levels of heat at those different fractions. Okay, now I've gone a little bit extra in this question. It's only a 4-mark question. However, I added a few more bits just in case the examiner may not understand or your message hasn't been put across properly. You have extra marks to cover for those possible marks that you lost, okay? So number 1, crude oil is heated and turned into a vapor. That will be 1 mark right there. Crude oil is pumped into the fractional column. As the gases rise, the long hydrocarbon chains condense, and the small hydrocarbon chains rise up the fractional column. We can just, for sake of right now, we can say that's another mark, okay? Small chains have weak intermolecular forces, long hydrocarbon chains have strong intermolecular forces, okay? That could very easily there be 2 marks, all right? And making a total of 4 marks there. Therefore, small chains needs less energy to turn into gases. That could be another mark. Condensing at the top of the column, the fractions have different boiling points. And that could very easily be another mark, okay? And the reason why I'm showing you this is because it's better to have extra marks where the examiner can actually add marks together rather than having less marks, okay? So if you have finished all the way to here, where it says the small chains have weak intermolecular forces, that would only given you 3 marks, All right, so it's always better to add extra points to get those extra marks just in case. Okay, so we would have all marks in this question. Question 1b. Fuel oil is one of the fractions from crude oil. Power stations burn fuel oil to generate electricity. The waste gases from the combustion of fuel oil contain carbon dioxide, they contain water vapor, sulfur dioxide, and oxides of nitrogen or nitrous oxides. Okay, the waste gases are passed through a suspension of limestone in the water. Limestone is mainly calcium carbonate. Okay, calcium carbonate suggests how the use of a suspension of limestone decreases one of the environmental impacts that the waste gases would cause. Okay, what we got here is we got carbon dioxide as a greenhouse gas, water vapor is a greenhouse gas, sulfur dioxide when mixed with water produces acid rain, and nitrous oxides as well. Okay, now if we pass it through the calcium carbonate water as those gases are expelled, so the nitrogen oxides and the sulfur dioxide will be neutralized by the calcium carbonate, right? Preventing acid rain, because when they get mixed with the water in the atmosphere, they fall down as acid rain. Then, in the case of carbon dioxide and water vapor, they're also going to be neutralized, preventing greenhouse gas effects. Okay, so now we got question 1c. Some fractions of crude oil contain large hydrocarbon chains. Okay, some of them contain large hydrocarbon chain molecules. Hydrocarbon molecules such as decane, all right, that will be 10 carbons. 10 carbons, can be cracked to produce smaller, more useful molecules. Write the correct formula of the third product to complete the chemical equation. You do not need to give the names of this product. So you have decane, right? Remember that when we're looking at the law of conservation of mass, it tells us that whatever amount goes into the reaction, in this case that there, because that's your reactants, after the arrow you get your products. It will be the same amount that you put into the reactant. So it says here that the amount of reactants that you put into the reaction will always be the same amount of products that you're gonna end up with in the end. Okay, now if you look closely here, all right, let me just zoom in that for you guys. There we go. So we got 10 carbons before. This is in the reactant. Before that gets cracked into smaller pieces, you have 5 carbons here, 3 carbons there. So you are missing 2 carbons, meaning that the next molecule, one of the molecules that are missing, will have 2 carbons, because 5 at 2 equals 10, and that's how much we started with. We started out with 10. Okay, now the same story goes for the hydrogens. You got 22 hydrogens when you started, then you have 10 and 8, that makes a total of 18. So you need another 4 hydrogens to make a total of 22. So the molecule that is missing is going to have 2 carbons and is going to have 4 hydrogens. Okay, that will be 1 mark. That's an easy peasy mark right there. Okay, remember your law of conservation of mass. Now we got pentane. Remember, pentane comes from pentagon, that which means 5. So that means that this molecule here has 5 carbons. Okay, is used to produce polypentene. Okay, now if you look at this polypentene, because that has a double E, we can tell that that is an alkene. Okay, and normally alkenes, the way that I remember this is that because they got double E, normally they will have a double bond. There will be the unsaturated hydrocarbon chains, right? Now something like decane, pentane, and decane and pentane, because they finish in ANE. Okay, I know that because there is no double E, there is no double bond. So every molecule of an alkane will only have single bonds. Okay, Alkenes, double E, double bond. Alkanes, single E, single bonds, okay? And this will be the saturated one. There will be no more space for adding anything else, while this one will be the unsaturated one, okay? So it says here, complete the equation and the display structure for polyethene. So what do we have to do now? Obviously, we got pentene over here. Poly means many, and pentene, many pentene. So basically, you're joining many of these molecules together to make that long hydrocarbon chain, okay? Of what we got there, that will be a single molecule, and it's pentene, it's got double bond. Polypentene will have a single bond because it's opening that bond to join up with something else, okay? Now if you see here, there is no line in that side and then is no line in this side as well. That's when this double bond opens, then the carbons can have an extra bond on the left and an extra bond on the right to be able to join to adjacent molecules of pentene, making the polypentene altogether. And then we put them in brackets with an N at the end, because that N value is the number of pentenes that have actually joined together, okay? So if that N had a value of 27, that means 27 pentene molecules have joined together. If it had a value of 30, that means the 30 pentene molecules have been joined together, and that's what that N stands for over there, okay? Some polymers are described as smart polymers. Suggest one property of smart polymers that is different to that of an ordinary polymer. And this might be a bit fictitious, it might just feel like it comes out of the movie, but it actually is true, okay? There are polymers which are called smart polymers that basically they have memory, shape memory. They have shape memory. What does this mean? This means that they have been made to retain a specific shape if the conditions are correct, okay? So for instance, maybe they made a smart polymer, then when it gets really cold, it goes back to its normal shape, or when it's really hot, it goes back to its normal shape. I don't know if you guys saw one of those Batman movies where his cape actually becomes stiff like a glider, and then once it hits the ground, it goes like a normal piece of fabric. And that is an example of a smart polymer. Well, by conducting an electric charge through the polymer, what will happen is that it will have that memory, the shape of the memory of that shape that was designed to have, that was of a glider. And when the electric current is not going through it, you would have the cape of Batman looking like a normal piece of cloth, okay? And that's an example of shape, of a memory shape, okay? It's also applied in vehicles where when they have been given a dent, they will either apply hot water or something hot to make it get back to its original shape, or they put an electric charge through it and the polymer will go back to the shape that it was made to begin with, okay? So that is the difference between a smart polymer and an ordinary polymer. Question 2. Crude oil is obtained by drilling into the earth crust. The diagram shows a section through the earth crust to show how this is done. So you got your the drilling rig, you got your surface, you got your non-porous rock, you got your oil, you got water, and somewhere around here, if this is the oil, this here will probably be gas. That will probably be methane gas that is just been collecting on top of the oil. And then it says here, crude oil contains many hydrocarbons. Which elements do hydrocarbons contain? That is a no-brainer. Hydrogen and carbon, okay? So your answer for that would be hydrogen and carbon. All right, so we got a diagram down here. It says crude oil is separated into separated by fractional distillation. The diagram shows a column used for this, okay? Now, this is one thing that I want to speak to you guys, okay? Question number 1 was talking about describing how fractional distillation works, okay? And it was a 4-mark question. You wouldn't want to spend more than 4 minutes doing that question, okay? You leave it, carry on with the rest of the questions, and as you go through it, you might end up with something that helps you, okay? So you could have left that first question empty, breeze through the rest of your test, answering whatever you could, and then gone back and then try to get some extra marks from that question number 1. But in this case, they actually give you a diagram, and this diagram will help you to be able to remember perhaps into how to fractional distillation of crude oil actually works. So it's always good to breeze through the question, read the question that you don't understand. If you don't get it, you're not very sure about it, leave it, move on to the next question, and then at the end come back, because eventually you will stumble across some bits of information that might jog your memory into the answers for those questions. Okay, now it says explain as fully as you can how fractional distillation works. Now this is a similar question to the one that we had before, and if you're doing foundation, you're very likely to get an actual diagram, and if you're doing a higher paper, it's less likely that you will get a diagram. They will expect you to know that by heart. Okay, so the same as before, the crude oil is heated and it goes into the fractional column. Because all the crude oil is turned into a gas, it will rise up, and the gas that have the long hydrocarbon chains, because as you go higher it gets cooler, they won't be able to stay in a gas state. Okay, so they will condense into a liquid. Right? And then once they condense into a liquid, they will be collected into the different fractions that you see here. Okay, anything that is too big, it will just end up being a residue, because they wouldn't be able to climb up the fractional column, because the number of carbon atoms is too big. Okay, now if you see here, you got petroleum gases between 1 and 4 hydrocarbons, gasoline 4 to 12, naphtha 7 to 14, and so on and so forth. Okay, so step number 1, the crude oil is vaporized and pumped into the column. That will give you 1 mark. When the fractions are cooled, they condense into liquids. That will give you another mark. The fractions with lower boiling point condense at the top, and the ones with high boiling points condense at the bottom. That will give you 3 marks right there. Okay, that could be the 1 mark, that will be another mark, that could be 1 mark there when the lower boiling points condense at the top, and that could be another mark there. Okay, so we talked about 4 different things, right? 4 things to get 4 marks, although it's only 3 marks. Okay, now you got to be careful in this here. You don't want to over elaborate and go for a full 6, 7 points, okay, because the question is only 3 marks. Even if you get all of them right, you're only going to get 3 marks. So you gotta make sure you judge that, and the only way you're gonna be able to learn that is to practice exam questions. Okay, that is very important. Question 2b.2, naphtha burns more easily than diesel oil. Explain why. Okay, if it burns more easily, means that you need less energy to break the intermolecular forces, and the reason for that is because the naphtha hydrocarbon chains are shorter than the diesel hydrocarbon chains. And there you have it. Naphtha hydrocarbon chains are shorter than diesels, right? Therefore, they need less energy in order to burn. Now, triple I here, naphtha contains a saturated hydrocarbon with the formula C7H16. Draw the structural formula for this compound, okay? So first of all, C7, we're gonna have 7 carbons. So we got, there we go, 7 carbons, and it's gonna have 16 hydrogens. And there you have it, 7 carbons, 16 hydrogens, and it's a saturated hydrocarbon, meaning that it's gonna have only single bonds and there is no more space to add anything else in there. Okay, if it was an unsaturated one, you will have a double bond somewhere, which means that you could still add stuff into that chain. Okay, and that will be 7 marks altogether. Well, there you have it, guys. That's all I got for you now. That was chapter 9, fractional distillation. If you do have any questions, please do let me know. Write it down in the comments and I'll try to get back to you as soon as possible, okay? We're doing a couple more videos about exam practice questions, specifically maybe the topics in paper 2 for your chemistry. But if you got any specific requests, please drop us a message and then I'll try to make a video about it as soon as I can, okay? So remember, knowledge is power.